Hello, Mr. Lee here. All right, so for your final review, this is numbers 1 through 3. The directions are find the x and y intercepts. So you can solve this algebraically. The main concept is when you have a y-intercept, your x value is 0, right, because it's going to be on the y-axis. And then for an x-intercept, your y value is 0, because it's on the x-axis. Okay, so eventually we're going to show a visual of the graph, but algebraically we can just plug in a 0 for the x value to solve for the y-intercept, and then vice versa, plug in a 0 for the y value to solve for the x-intercept. Okay, so let's do y-intercept first. Should be a little bit easier. Your y is already isolated, so y equals square root of 4 times 0 plus 64. Once you simplify all that out, your y value is 8. Right? So when x is 0, your y value is 8. That gives you a visual. This gives you a visual of where the y-intercept is. Okay? And then when we're solving for the x-intercept, we're going to plug in the y value of 0. So it goes in this spot. This goes in this spot. 0 equals square root of 4x plus 64. And then this takes a little bit more work. You have to actually solve for the x value now. So isolate the x, undo all the operations. That will isolate the x. So in this case, we have a square root on this right side. Let's square both sides. So 0 squared is still 0. If I square the right side, I just get rid of the square root now. It's just going to be 4x plus 64. Right? And then from here, subtract 64 on both sides. And then divide by 4. You should get x equals negative 16. Okay? So these are ordinary answers. This is the y-intercept of 8. This is the x-intercept of negative 16. On the right side here is just kind of confirming visually and graphically that we have the right answers. Okay, so there we go. All right, number 2, same process. We're going to plug in our zeros where we need to. Let's solve for the y-intercept first. So y is equal to 0 to the power of 4 minus 81. Simplify gets negative 81. So there is our y-intercept. Solve for the x-intercept now. Your y value goes to 0, right? So 0 equals x to the power of 4 minus 81. This solving is a little bit trickier. You have to use factoring. Okay, we like this 0 here. This is not a quadratic exactly, but you can treat it as a quadratic essentially when you're factoring. There is one factoring technique called difference of squares. Hopefully this is familiar, right? The square root of x to the power 4 is x squared. The square root of 81 is 9, so you can actually apply this pattern of difference of squares like so. Okay, you can check this as well. If you multiply this out with your distribution, you will get this x to the power 4 minus 81. So difference of square patterns turns into this. And then furthermore, you can factor this. Your x squared plus 9 can't be factored any further, but we have another difference of squares here. This will turn into, what, x plus 3 times x minus 3. Okay, so this is fully factored form now. We can apply our zero product property. We're not solving for imaginary roots at this point, so this has no real roots. Okay, you can't square a number and make it negative 9, right, to actually counteract this to 0, right? But you can do it for these two factors, right? If you have x plus 3 equals 0 or x minus 3 equals 0, that means x equals negative 3 or x equals positive 3. So we should have two x-intercepts here. One y-intercept at the negative 81, two x-intercepts at negative 3 and 3. Let's graph it to make sure. There we go. All right, and number 3. So same process. For my y-intercept, I'm going to plug in the x value 0. This one you don't have your y all isolated. It's technically a y squared, so there will be a little bit of work to do. But you're still plugging in the x value of 0. Right, so this becomes what? Y squared equals 100 minus 25 times 0 is just 100, right? 25 times 0 is just 0. So we're looking at y squared equals 100. You should now have y equals the positive 10 or y equals negative 10. right? Square root both sides here. Don't forget the plus or minus. So you actually have two y-intercepts in this problem. So we have 0, 10, and then a 0, -10. Okay, those are the y-intercepts. We're still going to test the x-intercept by plugging the y value of 0 now, right? So it's going to be 0 squared, goes in the y position now, and then equals 100 minus 25x. 0 equals 100 minus 25x. Let's go ahead and move the 25x over to the other side. We get 25x equals 100, so x equals 4. Okay, so there is the visual again. We've already solved it algebraically. Y-intercepts here, x-intercept there. Let's prove it. There you go.